In the previous video we looked at objects that are typically orbiting stars. In this video we're going to look at stars in a little bit more detail. So first of all, the definition of a star. It is a luminous object, and by luminous we basically mean that it radiates light, and it's basically a ball of gas. And most of the gases in stars that we observe is hydrogen and helium. And hydrogen and helium because they're the smallest and were the first elements that were created in the early universe. And that ball of gas is held together by its own gravity. So because there is so much gas there, the gravity of all of the mass that is present there in that gas causes it to sort of stick together. But there is an important point to note here as well. In a star, nuclear fusion is what produces the light that's being released, and that occurs at the star's core. That actually produces fairly high pressures. So you've got this gravitational force pushing inwards, but you've got these high pressures in the core of the star, and as a result you've got this sort of pressure pushing outwards, and with the gravitational force pushing inwards, and so as a result we end up with these two forces counteracting each other. And anytime we have two forces that are counteracting each other or acting in opposite directions and are equal but opposite, and so they counteracts the force of gravity, and because those two forces are equal but opposite, we end up in an equilibrium position. So with large masses of stars, that means that we get more fusion occurring in the core of the star, which produces more pressure, and so we get this equilibrium state being produced. We will have a look in a bit more detail at that later on in this particular unit, where we'll see that once that fuel source that's undergoing the fusion reaction, once that's used up, what happens in that sort of situation. Now again, we'll look at some examples. The first two being our Sun on the left, and you can see that it's very sort of red or orange looking, and on the right is the star Rigel. Again, the scale here is completely off. Rigel is about 18 times the mass of the Sun. It's about 74 times the size of the Sun, so it's a much larger star. You can see that Rigel is more blue, whereas the Sun's more a red colour. And again, we'll delve into those concepts a little bit later in this unit. Now, there are some interesting aspects about stars that we need to consider. The first is that we can actually have two stars that kind of orbit each other. It's known as a binary system. So a binary system, two stars that rotate about a common centre of mass. So not all stars are just going to be a single star by itself. In some cases, and in fact in lots of cases, we have these two stars that are orbiting each other. In fact, if Jupiter had been just a little bit bigger, if there was a little bit more mass in Jupiter, our solar system could have ended up being a binary star system, so with the Sun and with Jupiter being another star. It didn't end up having enough mass, and so it didn't undergo fusion in its core, and as a result just stayed as a planet. So this image here is of the binary star Alberio, sorry, and you can see these two stars here. They're in orbit around a common centre of mass, so they're kind of just sort of doing this dance through space where they're sort of rotating about each other. The next thing about stars we need to be aware of are constellations. Now, most people are familiar with some constellations. Constellation is basically just a configuration of stars, and not necessarily stars that are near each other either, just a configuration of stars in the night sky. And basically when we're seeing these stars as viewed from Earth, so when we're talking about in the night sky, we're talking about being viewed from Earth, so they're located close together when we see them, so not necessarily close together in space, that when joined by connecting lines, they appear to produce some sort of image, some sort of imagined image. And I'll have a look at a couple of examples again. Very imagined. So if we look at one that we know very well, so on the left we have the constellation known as Crux. You'll probably know it better as the Southern Cross. And the lines that we're going to draw in there, basically just the lines of the cross itself, so across that way. So there's the Crux, or the Southern Cross. On the right hand side we have Scorpius. So Scorpius relating to a scorpion. So the lines that we need to draw in there's these three here that kind of represent the claws of a scorpion. And then if we go across through these stars, we have sort of the body of the scorpion, and then around through to its tail at the back there. So it doesn't really look like a scorpion, but go back to the ancient Greeks, as they were looking up at the stars, they sort of imagined that represented a scorpion image. Now if we go to the next idea, the next grouping, we need to look at stellar clusters. So stellar clusters, as the name suggests, is a grouping of stars. So stellar clusters are just, as I just said, groups of stars that are gravitationally bound together. So while they're going to be fairly distant from each other, there's that gravitational attraction that pulls them into a grouping, and so they sort of act as a one large structure. Now we need to break that up into two smaller categories. The first is a globular cluster, and a globular cluster consists of tight groups of hundreds and even thousands of very old stars. So these are clusters that have been around for a long time, and over time the stars have sort of been pulled closer and closer together, and as a result very old stars in there. The second example then is known as an open cluster, and you can probably guess here that we're going to now deal with less than a few hundred stars. So far fewer in an open cluster, and the stars that we're dealing with there tend to be very young stars. So again, if we have a look at a couple of examples here, you can probably identify fairly easily that the one on the left is a globular cluster. It's Messier 5, and you can see quite a lot of stars in that, fairly tightly bound. And on the right hand side is the open cluster, the Southern Pleiades. So you can see far fewer stars in that, and much younger stars as well. If we then move on to the next, it's sort of not so much a star as such, but something that is important when we consider stars, and we'll see in star formation that it's an important stellar object to consider, is nebula. So nebula is the singular, nebulae, so with an E on the end would be the plural, but a nebula is an interstellar, and that word interstellar means that it's between stars. So an interstellar cloud of dust and gases. And again, the gases that we're talking about there are mostly hydrogen and helium. Fairly simply put, it's just an interstellar cloud of dust and gases. In the end, all stars are actually formed from in a nebula. Some will be produced, some nebula are produced after a star has exploded. But again, we'll look at that in more detail when we get through to the life cycle of stars. And some examples, as you can see, tend to be quite spectacular. So the one on the left is the Horsehead Nebula. You can sort of see why it's called the Horsehead Nebula. We've got this this shape in the middle that resembles a horse head. The one in the middle there is the Hourglass Nebula, and that was produced after a supernova. And likewise, the one on the right, produced after a supernova, is the Crab Nebula. So very interesting shapes, interesting patterns that you see in some of these nebula. Keep in mind these images aren't necessarily true colour images. Sometimes they have to be coloured or sort of converting radio waves or ultraviolet or infrared into the visible spectrum, so we can see more about the shape of the nebula itself. Generally speaking, you can actually see some nebula with the naked eye. If you look up into the sky, if you use telescopes, you can see some of them even clearer again, but some are quite large and quite spread out that they're very difficult to see. Some of them, in fact, can be much bigger than our solar system, so sort of thousands of light years across. And the reason why we can see nebula is not actually because the gas itself is producing light. It's usually reflected light from other stars in the vicinity. So some really interesting structures in nebula. Moving on, if we start to group our stars and nebula and all those sorts of bits and pieces together, we're now going to look at the next grouping being a galaxy. And a galaxy is just a system of millions or billions of stars. And again, you'll notice here we're going to be talking about sorry, I should also mention not just millions and billions of stars. It's also their planetary systems. But it's not just about having a whole heap of them sort of in a region. It's about having them gravitationally bound. So when we're talking any of these sorts of systems, it's always a key factor is that gravity is sort of keeping all of these objects together. Now, galaxies are likewise similar to nebula. They can be fairly spectacular. For example, on the left is the Milky Way galaxy, and you should be able to identify here that that is not actually a real image. We can't actually take images of the Milky Way galaxy looking out, so from outside the Milky Way looking back in. We've only just barely escaped our own solar system. So those sorts of images that you see of the Milky Way galaxy are more sort of artist interpretations. On the right hand side, we've got IC 1101. Now, IC 1101 is the largest known galaxy that we've been able to identify, and by large, I really think it's quite mind-blowing. So that the Milky Way galaxy that you can see on the left, that would kind of take up about this much, as you can sort of see there's a little bright patch in there. So the Milky Way galaxy would be sort of in that circle there. So IC 1101, really large galaxy, so very large structure out in space. We can then group galaxies together. And so the first, similar to when we're looking at stellar clusters, we've got clusters of galaxies, or galaxy clusters. And so a galaxy cluster is a structure consisting of hundreds of thousands of galaxies. So when we're talking a structure, again, we're talking about gravity having a bit of an effect. So hundreds to thousands of galaxies. And again, bound together by gravity. And one last one that we need to look at is a basically sort of taking it up a notch, a supercluster. And a supercluster, as the name suggests, is a large group of smaller galaxy clusters. So notice that we've basically just sort of stepped up group by group and ended up with these superclusters. And these superclusters are basically among the largest known structures in the universe. So when we're talking structures, we're talking about those forces of gravitational attraction that keep the whole thing together. So the last couple of example images that we'll have a look at. You'll notice on this scale it's really hard to start to identify where the structure itself is. But on the left we have a galaxy cluster that's known as El Gordo. Quite an interesting name, this one. Basically means the fat one. So it's the biggest galaxy cluster that we've found in the distant universe. And on the right hand side is the Virgo supercluster. So as I said, it's difficult to get a good sense of exactly what galaxies are in these clusters, or these superclusters. The Virgo supercluster is the structure that the Milky Way is found in. But like I say, very difficult to get a good sense of the scale and the size. But basically you can sort of consider that each of these little points of light here is actually a galaxy. So we've got all these galaxies that are in the same vicinity, gravitationally bound together. As we move forward now, we'll have a look at some of the properties relating to, say, the intensity of stars, the brightness, the colour, some of those sorts of ideas. And we'll start to bring some numbers and some equations into it to quantify some of these properties of stars and planets and other objects in the universe.